Hey, pre-cal 12, or 12, wow, pre-cal 11. Here we go, law of sines. So this is going to be the first introduction to um, a, a concept that allows you to solve oblique triangles like we just did using a sine law. So almost using a bit of a definitely a shortcut. But there are some things to consider and there are some pitfalls to look out for. So we're going to go through this. We're going to take our time. First thing is this is it right here. Now, the thing is when you're designing these triangles, it's very possible that you can design 1, 2, 3, or 0, given the information. And it matters because if you can't even create the triangle with the given information, then you're done. Right? One really important thing that's not in the notes, that probably should be, actually, and I'll add it at a later date, is that the two shorter, that's a highlighter, sorry. The two shorter sides of a triangle have to add up to greater or equal to the longest side. If they don't, your triangle doesn't exist. And the best way to kind of demonstrate this would be to draw 3 lines. Boom, boom, boom. Now those lines are all the same. If this piece were to fall inwards and this piece were to fall inwards, they'd connect at the exact point and connect, right? Now, so you would be able to create a triangle. Now, if you had a shorter one here, but this one was longer than the bottom, this would fall and hit that, right, as that fell in before the bottom. You still have a longer piece, so you're okay. As long as, sorry, I drew that wrong. Let me draw that again. Short, their matched height has to be more. So basically, as long as this piece and this piece combined are longer than the bottom, this will fall, and they will hit. Okay? If that didn't happen, so say you had something like this, right? There's no way those two side pieces will fall and touch one another. So the two shorter sides have to add up to greater than or equal to the longest side. If that doesn't happen, you can't draw the triangle. Okay, that's a little bonus. Now here is the law of sines, right here. It's a proportion. Sine A over its side is equal to the same amount as sine B over its side, which has to be equal to the same amount of sine C over its side. Now you'll see I have or this. You need to realize that you can flip this ratio equality, right? Because if you look at just these, you're saying sine A equals sine B when A equals B, right? Well, A equals B, sine A equals sine B. Same thing. You're fine. You can flip it. Reason why we do the flip is just it makes your algebra way easier, okay, when you do the flip and when you don't. Now, where does the law of sines come from, right? How do they figure this out? It actually comes from everything we just did. So it comes from manipulating obtuse triangles. So we dealt with both of these scenarios in the last section. If you drop a perpendicular here, right, you can say that sine A, we did this a lot in the other one, is equal to h over b. You see that right here, right? Which works out to be that h is equal to b times sine A. Now from that same one, you can say that sine B is equal to h over A, which works out to that. Since they're both equal to h, set them equal to each other. And then just divide sine A over times B by B. Cancel out the B, do it on both sides. You end up with this. And then divide the right side by A and the left side by A. You end up with this. So that is how we derived the sine law, right from what we just did in the last section. All right, so now using the sine law. And you'll see under the blank space, you see the ass triangle. I'm going to get to that one shortly. So here's the first example of using the sine law. You're given a bit of information. Okay, So you got the fact that you got triangle ABC, you got angle B is 29, angle C is 105, and side B is 30. So I'm going to kind of stick true to how I've been drawing these triangles. You got to be prepared to manipulate the letters. You can't hold fast to A is always in the bottom left. Now you just call A C, and now C is in the bottom left. It's not the end of the world. It depends on what you have. But I'm going to keep true to that because all I can see right now is C is a big angle. C is 105. So what I'm going to do is I'm going to draw that as a big angle. That's more than 90 up there. So I'm going to call that 105. Now this triangle didn't look as pretty as I wanted it to, but hey, what can you do? No, it definitely doesn't look. There. Okay, so that's C up there, and I know that B is 29 degrees. Now, from my drawing, this angle looks less than this angle over here, but hey, I'm just going to call that B. I'm going to work from it from there. If A happens to be less, great. If A happens to be bigger, then I just adjust your drawing or just trust your numbers, okay? Now, you know that side B is 30, and you know that that's it. That's all we know. We know that A is here and C is here and A is here. So we're just going to use the sine law, right? We can solve for angle A. Angle A is 180 minus 105 minus 29. So what's angle A? Angle A is 46 degrees. So now you can use the sine law. And this is why I showed flip. Because if you did the original, you would go, let's go sine B over B is equal to, I want to know C. So I'll say sine C over C. If you plug in the information you have sine 29 over 30 is equal to sine 105 over C. Unknown is in the denominator. It's just extra work. I don't really like setting myself up to do extra work. I don't know about you, but extra work, why? Right? Work smarter. So if you notice that your unknowns are your sides, then put your sides in the numerator. So I'm going to say, okay, well, C over sine C, which is 105, is equal to B. Now you can't use A because you don't know A, but you can use B. B is 30 over sine 29. And now how do you get rid of that sine 105? Multiply both sides by sine 105. So C equals 30 times sine 105 all over sine 29. Be careful with your calculator input. I would do this calculation here, hit equals, and then hit divide, and then I do sine 29. And C comes out at 59.8. Okay, so this distance on the bottom here, 59.8. And now what's left is just to solve for A. There's no awesome, can't do Pythagorean theorem, you can't do the 180 angles because we just have sides, so we just have to use the sine law again, right? So A over sine 46, and I'll use B again. Always nice to use the one you're given. You could use C now that you have it, but it's always nice to use the one you're given originally. So 30 times sine 46 over sine 29, which calculates out to 44.5. Now, if you look at the numbers you got 44.5, you got 59.8. Angle B is the smallest of the three angles, so the side should be the smallest. It is. Angle C is the largest, so the side should be the largest. It is. So that's your basic, straightforward use of the sine law. But obviously, nothing is as easy as that. You need to consider when you are given an angle, side. Now, if you look at this example here, right, the first one, you were given an angle, side. If you look at the way it was drawn, you had angle, side, which was an AAS. When you have an AAS triangle, you don't have to worry about the ambiguous case, right? Ambiguous case means the potential of there being more than one triangle, which is why it's a pain in the ass. Okay, you could have 0, 1, or 2. If you don't have the ambiguous case and your sides, like I said at the very beginning, your two shorter sides add up to more than your longest side, you're going to have a triangle. But when you're given this ass case, okay, the ambiguous case, the pain in the ass, you need to check to see if you're going to have one triangle, no triangles, or two triangles. And you're going to have to check every time, but only when you're given this type of triangle, okay? And only when you're given an angle, side, side. So this is case one right here, and there's a lot going on. This is going to take a lot to wrap your head around, but hopefully I'll make this as easy as possible. So case one, if you look at the way this triangle is labeled, angle B is down here, but I just don't know how long side A is, so I'm not sure where the connection of this triangle is, and that matters. So if A is less than H, all right, which means if this length here is less than the height, that arm will never connect down here. It's not possible because it would have to be bigger than the height. It would never connect here. It would never connect here, right? It would never connect. It would just dangle there. This arm of this triangle is just dangling, trying to find a place to connect on that C line on the bottom. And if it's shorter than the height will reach, but oh no, if that's A there, it's not going to reach. And it's just going to swing there. It's just going to be like you have this piece that just dangles and it just swings back and forth. You cannot create a triangle. No possible triangles. When A is less than H, you have no possible solutions. So what does that look like in action? Well, let's do a calculation. I have triangle ABC with angle A is 30 degrees, right? Side A is 4, side B is 10, find angle B. Now, if I were to do this way with respect to case one, okay, I would say, well, angle A is 30. I know that 30 kind of looks like that. Okay, so if I know that this is 30 degrees, I know side A over here is 4. I know B is 10, right? I'll call that 10 there. Well, what angle gets created over here with angle B? Well, I need to check and see what this triangle looks like. What's my height? And height is sine of 30 degrees is equal to H over 10. So 10 sine 30 equals H. So in this case, what's my height going to be, right? My height is going to be 5. But my A is only 4. A is less than H. No possible triangle can be constructed because this arm would be dangling here but would never make it to the length of the height. Now, right away you'll be like, whoa, 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 A is less than H, boom, we're done because this is an ASS triangle. But if you were to try this using the sine law and go, okay, well, I can do this because I know that sine A over A is equal to sine B over B. Multiply both sides by 10. Sine B. Here's where the problem is. If you calculate 10 sine 30 divided by 4, you get that sine B is equal to 1.25. Now here's a bit of a teaser for grade 12 and calculus. If you try to plug sine negative 1 of 1.25 into your calculator, you get error 2, or error 2. Most calculators will say error 2. That means that it does not exist. It'd be like if you tried to divide by 0, you get error 2. That means it's some mathematical not allowedness going on. If you get error 1, it just means you typed something in wrong into your calculator. It doesn't understand your syntax. Error 2 means no, 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 that's not possible, world explodes. Cosine and sine, right? Their trig ratios will never be bigger than 1. And that comes down to what we learned about that unit circle, right? The furthest that line goes is to 1. It never goes further. So it'll never be bigger than 1. All right? Good. So that's 2 ways to look at that one. Now, what about if there's only one triangle? How do we find one triangle? Well, one triangle is when A is equal to H. You create a right angle triangle. That arm doesn't dangle because that arm connects right at the bottom, right? If you think about, well, here's my triangle. What's my B going to look like? I got this arm dangling here. It's going to swing, except it's the length of the height. So as it swings in, boom, it connects and it creates a triangle. And finally, you have a triangle created. You have one triangle, okay? And I left this one just to look at because it's pretty straightforward. Once you know there's one triangle, you just use the sine law. Or in this case, Given an angle and a side, you could actually use Pythagorean theorem. Or sorry, you could actually use your, what's it called? I can't even think. Oh, no, sorry. You could, to find B, you know B is 10, to find A, you could find C using SOHCAHTOA, you could use Pythagorean theorem, and you know what angle B is, right? It's asking you, well, find angle B. Well, you know what angle B is because you know you've created one triangle. So it's going to probably be 90 degrees. Now, just because you have one triangle doesn't mean it has to be 90, but it's definitely 90 when A is equal to H. Here's an example of one triangle where A is not equal to H. But A is not less than H. A is bigger than B. So you'll see, in this case, imagine, right? Like you can see that one completed. Here's your triangle. But now this side here is so big, right, that it couldn't even be the height. It'd be bigger than the height. If it swung through to the height, it would like dangle down. It's too big. So if it's greater than or equal to B, you have also. So if this is B, right, if A is greater than or equal to B, you also have one triangle. Okay, and here we go. A is 30 degrees. So there's my A, right? And I know that A is 12, and I know that B is 10. So I know that whatever line I create here, I know that it's 10. I just don't know if it's going to connect there. I don't know if it's going to connect there, and I don't know if it's never going to connect. So I got to figure out, okay, well, actually, I don't have to do anything. Well, sorry, let me be clear. You can figure these things out, or you can actually just look at it knowing this case, right? Knowing that this is happening, you know it's going to connect here because 12 is bigger than 10, right? But you should check the height just to check and see what the height is, right? Because what happens if the height's 10? If the height's 10, then it's a right angle triangle. So, because it doesn't matter that A is greater than B, right? Because A could be greater than B. No, that wouldn't work. Just check to make sure it's not the same as the height. Sine 30 is equal to H over 12. 12 sine 30 equals H. So 12 sine 30 is 6. So the height's 6. So this is way bigger than the height. So it's got to touch out here. So you've created this triangle. You have A, you have C, and you got this angle B over here that you have. You know the height is 6. You know that this is 30. Well, how do we get angle B? Well, we know a side. We know a side. We can just use the sine law, okay? We have sine of 30 degrees over 10 is equal to sine of angle B over... I'm sorry, I totally drew this wrong. I wondered why it was throwing my brain off a little bit. So pause everything I said when A is greater than B. 10 is there, 12 is there. A is greater than B. So yeah, wow, sorry about that. Because, yeah, you got to check the height just to make sure the height's not 12, because if the height's 12, you have the right angle. But we're looking at this. So we're solving for angle B. Sine of 30 over 12 is equal to sine of B over 10. And then we solve for sine B, and you end up with angle B is equal to 10 sine 30 over 12. So angle B is equal to 24.6. And then you can find angle C. The important piece to be able to identify, and I'm just going to scroll up for a sec, is if A is less than H, if A is less than the height, you just say, okay, no triangle. I don't even really need to calculate anything. It's not possible. If A is the height, you have a right angle triangle. If A is greater than or equal to B, you have a big isosceles or oblique triangle. Now, why isosceles or oblique? This piece here, this A is equal to, see this drawing that I butchered the first time? If that was 10 and this was also 10, right, greater than or equal to, you have an isosceles triangle. So that's the one triangle you would make in that case. And if it was bigger, that's the one triangle you would make in that case. If it was exactly the same as the height, you'd have the one triangle that's the 90 degrees. And if it's less than the height, you have no triangles. So far this seems pretty good. I either have an isosceles triangle, a right angle triangle, an oblique triangle, or no triangle. Right? So why is this such an angry thing to look at? Because you got this baby right here, case 4, the ambiguous case. This is the one that you really got to look out for because there's two triangles. Now I'm going to do my best to draw this for you as best as possible. You can see the drawing here, but I'm going to kind of redraw it so you'll see exactly what I'm talking about. Okay? So first thing that I'm going to do, just to help your vision, I'm going to erase it later, is I'm going to cover up this. Okay? Because I'm going to explain where that all came about after. So I'm going to cover all this up so you're not staring at it. Because the whole time I'm working, you're going to be like, wait. Okay. So here is the case. If A is greater, so if this is bigger than the height, but less than B, you have two triangles. So here we go. Given triangle with angle A 30 degrees, A7 and B10. So right away I'm going to look at that and I'm going to say, okay, A is 7 and B is 10. So A is not greater than or equal to B. So I know I don't have only one triangle, be it an isosceles or an oblique. So I need to check the height. So I have this triangle. Right? For now I'm going to assume here, I'm going to assume that this works. Okay? But I need to check my height. That's my first step because I need to know what the height is. So find that first, right? What's the height? Well, sine 30 is equal to height over 10. So 10 sine 30 equals h. So h is equal to 5. Okay, so now you have a case where A is greater than h, but less than b. You're going to have two triangles that get created. And what are those two triangles? Okay, I'm going to erase what I after because I found height. How? It's like, well, wait a sec. Why two triangles? Two triangles because of the swing. So I want you to think about the swing motion of what's happening. You have this triangle here. This was length 10. And this is length 7. And we don't know that length, but we'll figure it out. It connects there because it's greater than height, right? If it swung through to the height, it would swing through to there. And it wouldn't exist. It would go too far. But you also have the fact that the arm could swing through, right? And it would swing from here around below the height and then back to here. And it would hit there. And you would create this mini triangle on the inside of the first triangle you created, which was this thing here. This, you see, it's also side length A. It's this arm right here that has swung through and reattached itself here. So the second triangle that we will be talking about that gets created is this thing here. Okay, that's the second triangle. And the first triangle is this one. So you need to solve for both of them. So I'll kind of redo, I'll go green down here because this is the first triangle. And then this is the second triangle that also gets created. So two triangles are possible. Now the thing to really look at is, since this is A and this is A, these angles are the same because they're creating the angle with the same bottom line, right? So this is angle B in our drawing, and this is also angle B in here, which means that this is 180 minus angle B. That's what that's going to be. And this is angle C up here, and this is going to be a different angle C. It's going to be angle C prime. I don't know what it is. This angle A is the same in both triangles. 30, 30. Now the good news is, this is relatively easy to figure out for the angle. Because if you look at the first triangle, all we want to know is what's angle B. Well, we can use the sine law, because we can say, okay, well, sine 30 over 7 equals sine B over 10. And then you calculate that out, right? 10 times sine 30 divided by 7. You get angle B is 45.6 degrees. Well, obviously this angle here is not 45.6 degrees because it's greater than 90. So this angle is 45.6, and this angle, I don't want to, drawing blue everywhere, one sec. This angle is 45.6. Well, so this chunk, the other piece of angle B, so we'll call it angle B prime, is 180 minus 45.6. Now I'm going to do an example a little while that shows solving everything. But you have two possibilities for angle B depending on which triangle, that one or that one, you've created. So that is the ambiguous case. You must check height. As soon as you notice that A is not greater than or equal to B, you need to check the height, because that'll tell you whether or not you have a right angle triangle, no triangle, or two triangles. Okay, now all of those cases, angle A was acute, right? Angle A was less than 90 degrees. There's a small two other cases here where A is obtuse, and they're actually rather straightforward. It's either one triangle or no triangles. There's no ambiguous case here. So if you're looking at your original, if the question is being posed to you and it's like, oh, angle A is greater than 90, I only need to worry about one thing, right? If A is less than or equal to B. So think about that. This is your angle A that's down here, which means that this is side A. Now I don't care where you draw B, but it makes more sense to draw it over here just looking. Here's side B. Because picture, here's your construction. You've created this arm up here, right? And you have this arm here. Naturally, this arm is longest. So if it's shorter than this arm here, this arm B, it's never going to connect anywhere along here. And the triangle wouldn't be able to complete itself. It would just look like this. And it would just, dangle and swing. You would never have a triangle. So if A is less than or equal to B, there's no solution. And what you'll notice if you try to work this out using the sine law here, you'll get that sine inverse of a number greater than 1. And it'll come up error 2. Does not exist. The other one is when A is strictly greater than B. So if you go just back for a sec, this is when A was less than or equal to B. Right? This wouldn't work if A was less than or equal to B. Equal as well, because what happened if it was equal to B? It would just swing and lie right back there. It would never connect. It would just be a line. Line on a line, right? So you have one triangle when A is greater than B. And this is just a very straightforward sine law question. You have angle A 120, you have side A 12, you have B is 10. A is greater than B, we know we're going to have one triangle. What's angle B? Sine law. So sine of 120 over 12 equals sine B over 10. Work that out, and you're going to end up with that angle B is equal to 46.2 degrees. Okay? So that's the sine law. And it's not about how easy is it to use. It's about when can I use it. You got to make sure that you're okay to use it. There's an example down here that's going to take a couple minutes because you're going to notice that it's going to be it's an ass triangle. So you've got to check the ambiguous case. But one thing I want to show you first is the summary page. Okay, so this is everything we talked about. You got your sine law on the top, then you got how to solve for H right here, and then the cases. So if A is acute, if A is less than H, no triangles. If A is equal to H, one triangle. If A is greater than or equal to B, one triangle. The only time you really got to worry is when A is greater than H and less than B, two triangles. If A is obtuse, no triangle if A is less than or equal to B, one triangle if A is greater. And then there's a little, this was bonus about the unit circle at 0 and 180 degrees, sine t is 0. Not really worried about that for right now. Here, sine is never, sine and cosine, but sine is never greater than 1 or less than -1. And for the ambiguous case, doesn't have to be written in gold, but it's just easier for when you're drawing. Okay? Put the given angle in the bottom left corner. Put the given side respect to that angle on the far side, and put the other given side here. Put your missing side on the bottom. It just helps for drawing. And you'll see why I've labeled this the way I have is because in every case I gave you is ABC, 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 right? But look, the information given to you here is not ABC, it's B and C. So all that means in this case is, instead of calling this angle A, that's my given angle. This is my given side with respect to my angle, and this is my other given side. So you just change the way you label your triangle, but everything works the same way. So it's not, and this is the thing, is it's not now that A is less than H, it's B is less than H, because it's the side that matters, not the letter. The reason why I make emphasis in this is because different textbooks might use different letters. Different places you see things might use different letters. So don't get obsessed with the A is less, the A, but that side that's represented by A. In this case, it's represented by B. Be able to have a flexible mind for that. Now, what I'm going to do here actually is, this question is long. It's on the workbook completed on the website. Have a look at it there. What I might do is do an extra video for the ambiguous case, but this has been a long enough video. So read through this on the website, okay, on the actual completed workbooks. And only 2 videos to go until you are technically finished. Congratulations.